We are working on the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we saw how we are going to approach the problem of finding neighbors. In this video, we will write a function to basically implement that approach. Remember, the basic idea that we had was to treat every square as a center square. Now, for a center square, the neighbors come from the row above, the row below, column to the left, column to the right, and also the same row and column. So what we do is to create two lists, call them temp_c and temp_r, and then basically look at every combination of, let's say, the values here. However, we must remove the cell, the square itself, and that's what we are doing here. So this function is going to return me a list which will have neighbors, assuming that the square that we are talking of is a center square. So for center squares, obviously this is correct. For the edge and the corner squares, we will have to make some adjustments, as we'll see a little bit later. So I get to my code over here. I just, define a function to say, well, def, let's say, find NEIGHBORS. Now to this function, I'm going to pass two parameters, R0 and C0. So it's like saying that, look, this square is at location R0, C0. Please tell me all its neighbors. I create a list called NN, an empty list. This is the list that I'm going to return from the function. So I just say maybe, let's say return the list of neighbors of the square, say R0, C0. I'll put this comment, let's say, a bit here. Now, like I said, I'm going to create two lists here. Temp, say temp C is equal to C0 minus 1, C0 and C0 plus 1. And I'll similarly create a temp, let's say R, which is basically for the rows. So say R0, so R0 say minus 1. Let me make it more compact so it's cleaner to read. So R0 minus 1, say R0, and finally R0 plus 1. Basically, this will create two lists for column and row respectively. Now I'm going to look at all the combinations of these, let's say temp R and temp C. So I can do that with the nested loop. I can just say, well, for R in temp, let's say temp underscore, let's say R. For C in temp underscore C. And what I do is to append this tuple to the, let's say, the NN list. So tuple, let's say RC, I append that to the NN list. But remember, this process has also included R0, C0, R0, C0, which is the row and columns value for the square that we're looking at. Obviously, that cannot be its own neighbor. So I go and remove, let's say, say R0 and C0. Now, important here to notice that there are two brackets here, because remember the items on this list are all tuples, and hence it's this tuple that I'm removing. Remember, tuples are covered with this round bracket. Now I will go and say return, let's say NN. Now clearly this function so far assumes that every square is a center square. We can see, so when I run this, for example, I can let's say I say NN is equal to find, say find neighbors of, let's say 2, 2. Well, if I look at NN, that's 1, 1, 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2, 3, 3. This is no surprise at all. No surprise at all, because what's happening, remember 2, 2 is this square. Its neighbors come from the column on the left, the column on the right, the row on the top, the row below, and basically all combinations thereof. And hence we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 3, 1, 3, 2, 3, and 3, 3. So that's exactly what we are seeing. This list NN, if I look at the length of this, it is 8 because there are 8 neighbors, and each of those neighbors has been basically represented as a tuple. We can take one more example. Let's say I go and say, well, tell me the neighbors of, say, 6, 4. Now again, this is the center cell. When I look at the, let's say, the neighbors of the square, they are as shown here. Again, 8 values, And clearly it's making sense because essentially 6, 4 is here, square B. Neighbors are on the fifth row, this column, seventh row, and finally on the fifth column. So all those combinations are available here, exactly what I'm saying. Now, obviously this works for the real sector cells. In the next video, we'll see how we can update this function, a very simple, very interesting update, so that we can account for the corner and the edge cells as well in a unified manner. As before, I hope you found this interesting. We always approach problems in a slow, systematic, step-by-step manner. As we build our activities, look at ybyte.in. All our curriculum is available there. You can take a look at many activities that we have worked on for learning Python. Take care. Thank you so much. Bye-bye.